So we will begin our session with single linked list insertion at the end, right. So we have already studied about inserting an element at the beginning. Now let us see how do we insert an element at the end. So in this case, what we have to do, already there exists a list with elements 4, 15, 7, and we know that always the first element head points to the first element and last elements next will be null. The last elements next will be null. Now what you have to do, you want to insert a new element at the end here. After this null, you want to insert a new element. Again you have to write command to allocate memory, then store some value and make this null. Those three commands are common like this. Here you see this is used to allocate memory like this, and these two statements will fill the data in this way. Okay, so these three things are common when you want to create a node in memory with 30 and null. Okay, so that we will do, we will get this structure. When we do that, we get this structure here, right. Now what we have to do, I have only one pointer. If you see, we know only one pointer head which is pointing at the beginning of the list. What I have to do here, somehow I have to reach here. I have to reach at the end of the list. How do I reach at the end of the list? I have to traverse through the list. From the head, I have to travel and reach the end of the list. And how do I know which is the last node in the linked list? We know always that the last node of a linked list is always null. So I have to iterate. I hope you remember we have seen one program on traversing a linked list. On traversing a linked list. You see what we have done? We have taken a temporary node here. We are taking a temporary node, checking if this value is null. If this is not null, move forward. See, we are doing a temp equal to temp next. Check if this is null. No, again move forward. Check if this is null. No, again move forward. Check if this is null. Okay, stop here. So this is your temp pointer now. This is your temp pointer. So the temporary is pointing out here. Okay, so this way, using this code, you have to traverse to the entire list and reach to the end of the list. Same thing we have to do here as well. When you are inserting an element at the end, first you should write the commands or the statements required to create this. Once this is done, you have to traverse through the list and reach the end of the list. Once you reach the end, so your temporary will be pointing here. What is the only command what we have to do? Temp next is null for now. Temp next is null. Just we have to do one command. Temp next, which is null, should be pointed to new node. If you do, this will be pointing to the new node. And already this is null. There is data. That's it. So with only one operation, we are inserting a new element at the end. What are the steps in this? First thing, you have to create a temporary pointer. So head and temp should be same. Why are we not using head? Because head should be always pointing to the first node. We should not touch head pointer. If you touch it, you will lose the control over the entire list. You do not know which are the elements before the head, right? Head always indicates that it is the first element in the list. So create a temporary variable temp, which is also pointing to location where head is pointing. From here, keep iterating. If temp's next is null, if it is not null, move forward. Check if this is not null, move forward. If this is not null, stop there. So once you reached here, your temp is here. Your temporary is pointing out here. Now just temp next, whichever current value of temp next is null, that you replace with new node. It means this which was null will be pointing to this new node. So the link has been formed, and here there is some address has come, and anyhow the new node's last one is null. New node's last element, the address is null. That's it. We got a new list like this by null at the end and head at the beginning. Okay. So this way we try to insert an element at the end. Only point here is you have to traverse the entire list to add a new element. Okay. You have to reach here. If the list, maybe we will see at the end what are the drawbacks of this linked list implementation again, right. To insert an element, I have to traverse through the entire list and reach the end point. What is the condition to know the end point? That the temporary pointers next location will be null. Till that you have to traverse. Let us see the implementation here. So again I am calling a function insert at end. I am giving head as the input and the new data which I want to insert I am giving as the input. So I am creating two variables. This is star temp here. So star new node and star temp. So why I am creating this? I am creating variables. I am creating two variables for this structure. I am creating two variables for this structure. Then I have new node equal to struct. This is the type of the memory you want to allocate and how much memory you want to allocate. So with this command in your RAM memory, this block will be created. It will be reserved for this and its name is new node. Next, new nodes data equal to data. This data is the one which is passed here. So somebody has given 10 for example, 10 will come here. Then new nodes next equal to null. These three commands are fixed always. Okay, these three are fixed always. New nodes next equal to null. This will become null now. This is ready. Now what I have to do? I have to iterate over the entire list. Before that, always it's a mandatory check to see if the list is empty or it has some element. So if the list is empty, this is the case. If list is empty, what you have to do? This is the only element in the list. This is the only element in the list. So I have to make this as head. That's it. If you make this as head, over, because there exists no element in the list. This is the only element in the list. So for that we wrote the code. Why am I writing this always head of next equal to null? To make sure that this is null second time also. Else what is the case? Else while temp next not equal to null. That's what, no, we have to keep checking. This is our temp. While temp next is not equal to null, keep moving forward. How to move forward? Temp equal to temp next. So temp next means this becomes your temp. Now check, is this null? No. Then this becomes our temp. Is this null? Yes. Stop here. So temp has been reached in this position. Once you reach in this position, the only command what you have to do here is just temp next equal to new node. So what I am trying to do, this temp which temp next is pointing to null. This you attach it to new node. Just one step. Temp next equal to new node. See here, temp next equal to new node. So these two lines is for traversing the entire list and reaching the end point or the last node of the list. Then we have temp next equal to. So this command is linking the last node with the new node, which is already null here. That's it. So this is the code to insert an element at the end. Okay, I hope it's clear. Any doubts here? How to insert an element at the end? Shall we proceed to the next operation? See, the second operation on single linked list is that inserting an element at the end of the list. So already you have a list with you. You want to add a new element. See, why we are doing these operations? When we studied the differences between linked list and arrays, we said that in arrays, inserting or deleting an element at any given location is not possible. You cannot add a new element or you cannot delete an element from an array. So we have chosen linked list as the alternate option for doing those kind of operations. Now in linked list, we have the feature or facility to add an element at the beginning of the list. Here you can add, or you can add an element at the end here. So we have seen how to add an element at the beginning. Now the question here is, how do you add an element at the end of the list? And we always know that in a given single linked list, the first pointer, the first node, head is pointing to the first node. Head is a pointer, it is always pointing to the first node. And the last node of the list contains null. The last node of the list contains null. So I have some data like this, 10, 20 and 30. So this is pointing to this. This way the list exists. Now what I have to do, I want to insert a new element here. So we want to add a new element here after 40 with value 50 I want to add. So you have to create a node like this, put 50 there, put null here. One step is over. With these three commands, we can create a node like this, put 50 into this and make this as null. This is fine. Now in the existing list here, till here, I want to add at the end. It means after 40 I want to add. How do I reach to this 40? How can we reach to this 40? We can reach to 40 only by traversing this entire list. So how do I traverse it? For traversing, what I have to do? I have to take a temporary variable temp. After taking a temporary variable, why am I taking temporary variable? Because I cannot touch head. So take a variable temp and check if temp's next is null. If it is not null, move forward. If it is not null, move forward. If it is not null, move forward. If it is null, stop. So this becomes your temp now. So you have traversed the entire list and you have reached the end of the list. From here what you have to do? Just make this connection. Just form this connection, that is temp next equal to new node, right? Temp next equal to new node, right? I hope you understood now how to include a new element or how to add. So this is just a check. If the list is empty, you have to point it null, but these two lines for traversing and this single line just to attach that last node with the new node. To form this connection, this one step is enough. Okay, right. So let's move forward to the next operation, inserting a new element at any given location. Okay, till now we have seen adding an element at the beginning or adding an element at the end. Now I want to insert a new element at any given location. Means if there is a list like this, this is an existing list and we have head pointer here. So the elements are 1, 2, 3, 4, 5 and this is null. Okay. Now let us assume the variable as position. So this is position 1, 2, 3, 4, 5. We have 5 elements and every element has some position. Now the question here is, I want you to insert a new element at position 3. Means after 2 here I want to add a new element. In between 2 and 3 I want to add a new element 20. Okay, between 2 elements, after 2 and before 3 I want to insert a new element. Or maybe somebody tells you, let the position be 4. It means I have to add a new element between 3 and 4. So how do we add that? Let us try to analyze how to insert an element at any given location. It depends on the location. We will be given some position. Okay, we will be given some position, right? So this is an existing list. If you see, our head is here. The list contains 4, 15, 7 and 40. When you have a single linked list like this, we want to, they are saying insert an example, insert an element at position 3. It means here I want to add a new element in between 15 and 7. So how do I insert a new element? For that, the first step is to create this node. So we know which all commands will help us in creating this node. Assume that is done. After that, your position is 3. It means you have to stop at the second position only. Okay, your position is 3. It means you have to stop at position 2. There you can insert a new element like this. Okay, so the first step here is that wherever you just create this, iterate. The position given is 3. They want to add a new element at location 3. When it is 3, you traverse the list and reach till 2. Traverse the list and reach till 2. So this is my temp now. I am stopping it here. This is my temp. Now temp next, you have new node with you here. You have new node with you here. This is the temporary node which I traversed. Okay. Now from this temp, what you should do here, this temp is pointing, let us take position 1, 2, 3, 4. I want to insert an element after 2. So I reached here by traversing logic, let it be temp. Now what I have to do, this new nodes next, which is null for now, this you have to point it to temps next. See, temp is at 2, temp next will point to 3. Temp, if I do temp next, it will move to 3. So new node, this is my new node. So new node, it's new nodes next. What is the current value of new nodes next? It is null now. This you point it to which variable? Which variable should I point? I should point to 3. Which is 3? Temp next equal to temp next. Okay, first to do that step. Because of this, what will happen? A link will be created between new node and element at position 3. So position 1, 2, 3, 4. So this link is created now. Then once you create this link, then you break down this link and bring it to here. How to do that? This is my temp node, right? Now write temp next equal to new node. Okay, with these two commands we can insert an element at any given position. Logic is very simple. If you have a list with 100 elements, 1, 2, 3, so on, 100 locations are there, you want to insert an element at 45th location. Then traverse the list till 44, stop there. Let the 44th node be your temp. Okay, already there is 45th node exists. There exists another node 45. Okay, in between you want to insert. So this temps next you point it to 45, 44 next you point to temp. That's it. With that you can insert an element at the beginning, right? So let us, I hope you understood the logic here. Whatever is the length of the list, you see the position. If the position is given as n, traverse the list till n minus 1. Stop there. Then after stopping, new nodes next, which is currently null, should point to this temp nodes next. That way you can form this link. Then you break this link by simply this temp nodes next to this new node. Don't do this, don't break this first, don't bring it here like this. If you do that, if you bring this node to here first, we do not, this chain does not exist, this chain is gone. So we lost this entire list, we do not have this list with us. Okay, the elements will be only 3. So that's why first point this new nodes next to this node, then bring this to here. That way we can do. Okay, so let us try to understand the code and let's see. Again, I am inserting at any position. For this, the input is the head pointer, the data which I want to insert, and the position, which position you want to insert. So you see, these 3 commands are fixed. Why? These 3 commands will help me in creating a node and inserting some data and null like this. These 3 commands will help me to create a node, reserve some memory in my RAM with value 10 and X. Let me call this as temporary node. We can call this as new node. We can call this as new node because this is one we are going to create. This is our new node. Now what you have to do, again as a mandatory check, verify whether the list is empty. If the list is empty means this is the only element in the list. You need not add anything. Just make this as head. Just make this as head. If this is the only element, make this as head and mark it as null. Okay. No, if there exists some lengthy list already, assume there exists some lengthy list and you gave position as some 5. You want to insert an element at location 5. See, while k less than position minus 1. So k is some variable 0. K is some variable with 0. So what is the position given to us? 5. So 0 less than 4 and temp next not equal to null and temp next not equal to null. Temp is also pointing to head. Temp is also pointing to head. Right. So what you are trying to do? If temp next is not equal to null and 0 is less than 4, just move temp next, temp equal to temp next. In that way you are traversing the list. You are traversing the list. So 0 less than 4, okay, 1 less than 4, okay, 2 less than 4, okay, 3 less than 4, okay. So you have reached 0, 1, 2, 3. You have come here. Now what will happen? 4 less than 4, it will fail. 4 less than 4, it will fail. So this becomes your temporary node. This becomes your temporary node. So this is my position 1, position 2, position 3, position 4. I want to insert an element at position 5. It means my temporary is pointing to position 4 element. Okay. Now what is the step? Once you do this, new node, we have a new node here, right? You have a new node here. New nodes next, which is currently null, this you point it to the next, temp of next. It's next, it has some value already like this. It has some value already here like this. So this next, see here, this is my new node, this is my temporary node, this is my temporary node. It's next, this new nodes next, I am pointing to this node. Okay. So new nodes next is temp next, then temp next equal to new node. So this you are trying to attach, this you are trying to add it to this. That way you can insert an element at any given position. Okay. I will repeat this once again. Please understand the code. We are learning this in bits and pieces so that it is easy for us to understand. Right. Inserting at any given position. Here when you have a linked list with you, you want to add an element maybe at 5th location or 50th location, like that. Okay. So the input is the new data which you want to insert, that element 10 and the location 5. These two inputs you have to give to the function. So then I am using these 3 commands to reserve some memory, to create a memory block in your RAM, right. So this box will be created and this element and the null. So element 10 and null will be inserted here. After this, if head is equal to null, if the head which is given to us is null, it means there is no element in the linked list. This becomes your head and this becomes your only element in the list. That is the code. We are using this for every case, inserting at beginning, end or at the end. Next, you want to go to position 5. You want to insert an element at position 5. It means you have to iterate till the position 4 and stop there. So for that, for some variable k, let k equal to 0, this you include in the program. Let k, so while k less than position minus 1, while k less than position minus 1. So k means 0 less than 4. Till this is true, you keep iterating. What will happen with this while loop? With this while loop, inside the body, what do you have? Temp equal to temp next. So you are moving forward, you are moving from head node to next node, then to next node, then to next node. Like this you will reach to the 4th position. This will be your temporary now. After this, it's very simple. New nodes next, new nodes next, this one, this location, point it to temps next. There is one element here, point it to this location. Then temp, where is temp? Here. Temps next here, this you add it to new node. That way you can insert an element at any given position. Okay, don't get confused. Try to understand the logic what we are doing here. This code snippet you have to understand how we are writing it. Okay. Any doubts in this? Inserting an element at the beginning, end or any given position. Students, please let me know if you have any queries here. Inserting an element.
The full code?
Yeah, we will write, we will implement this in C++ and C. But if this logic is clear of inserting at 3 different positions, we will go for writing the code.
Okay, sir.
Okay. So please ask, don't get, because this is very, very important. Don't simply be in some assumptions. If you don't understand, please ask, get it cleared. I can repeat it multiple times, because these kind of questions they ask in interview especially. If you ask me my experience, data structures is important in that we have so many programming questions, but less on linked list based problems. We have problems on linked list based problems, but more questions appear in placement or competitive exams based on other data structures, little less on linked list. But in interviews, in face-to-face technical interviews, they ask you this code snippet. They will give a list like this. You will be given a list, some list like this. If I say, yeah, this list will be given to you. They will say, write the code to insert an element at some given location, like this. Okay, write the code to insert an element at some. So you have to write that code snippet. How will you do that? You will say, I will first take the position as input. I will take the data which I want to insert as the input. Then I will traverse the list here till here. Let this be my temporary pointer. Then I will put my new node here. This is null and this is 10. So this I will point to this and this I will bring it here. That logic, this code which we have seen, this logic you have to write in the interview hall on the pen and with pen and paper. Okay, so this is very popularly asked. Right? I hope it is clear how do we insert an element at any given position or inserting an element at the beginning and at the end. Okay, is it clear? Right. So we understood how do we insert an element at the beginning, at the end and at the any given position, right. So with this we complete single linked list operation. Next we will see the implementation of single linked list.